Okay, I'm going to attempt to model the Chapter 4 test in Algebra 2 on this practice test, which is page 291 to 294, which happens to be the chapter review. And I would do number 6, 11. I had to make up an interest question or two. I put it in here. Then 17, 18, 20, 28, 31, 32, 33, 34. Some good questions. We have them written out, and we're going to go right through them now. We want to graph this. So to graph 5 to the x, first I probably need to determine whether it's growth or decay. Because the base 5 is greater than 1, that makes it a growth function. So I do know that this is a growth function. When I make an xy table, I always make the whatever makes the exponent 0. So what's 5 to the 0? Well, that'd be 1. So I know it goes through 0, 1. Many of the exponentials will go through 0, 1. If you put in a 1, what's 5 to the 1? Well, that would be 5. So 1, 2, 3, 4, 5. So it's going to go through this point up here, 1, 5. You know that most exponentials have a horizontal asymptote at whatever is added on the end. So because this thing really has a plus 0, that's where your horizontal asymptote is. And you know it's a growth, so let's see if we can just have enough information to sketch it. I believe it's going to do something like this. If you put in a negative 1, what's 5 to the negative 1? 1/5. So it's going to go through a point over here, negative 1, 1/5. I would like some points, if you could label some points, that will help. But I definitely want to see the asymptote. And an XY table is good also. Now that is a growth because the base 5 was bigger than 1. This one, the base here is 1/3. 1/3 is less than 1, so I know that this is a decay function. Okay, this is a decay function. If I make an XY table, again, I always put in what makes the exponent 0, so the exponent 0 would make if this was a 0. 1/3 to the 0 is 1, 1 minus 4 is negative 3. So I know it's going to go through 0, negative 3. So I'll make a point down here. 0, negative 3. Now, did I tell you that whatever is added or subtracted at the end is what's called your horizontal asymptote? So your horizontal asymptote is going to be at negative 4. So you have y equals negative 4 as your horizontal asymptote. If you know it's decay, you could probably just sketch it right there. Don't go through the asymptote. But if I put in a 1, what would I get? What is 1/3 to the 1? 1/3. 1/3 minus 12/3 is negative 11/3. And that's negative what? 9 and, I'm sorry, 3 goes into there, 3 and 2/3. So basically it's down here, negative 3 and 2/3. And it's going to be a decay function approaching the asymptote. So basically all I'm going to give you on the quiz is not too many fancy ones, a basic growth and a basic decay function. These you're going to need to know the formulas, or I will provide them for you. Compounded quarterly, you have to use this formula. 1 over r to the r divided by n raised to the nt power. N is how much, A is the amount in the account. P is the principal or the initial amount. So how much was the initial amount? 1,000. So that's what P is going to equal. If you don't mind, I may do these simultaneously. The formula for the one on the left, compounded quarterly or n times per year, you have to use that formula. If it's compounded continuously, you use A equals P e to the RT. Either way, the principal is 1,000. That's the initial amount. Now, the rate is the percent as a decimal, which you move it 2 places. 8% would be 0.08. So the R here is 0.08. T is the time. So what is the time if it's 5 years? Time would be 5. Time would be 5. I'm filling in for the T. N. N is how many times it's compounded per year. If it is compounded quarterly, that means N is a 4. So I filled everything in. Now it's just a matter of using my calculator. You're right, I didn't neglect an N here. The N should also be a 4 out here, right? Because it's 4 times per year. So I have one. Way I would do it on my calculator is I would do 0.08 divided by 4. That gives me a decimal. Add 1 to it. Raise it to the 20th. And multiply by 1,000. That gives my amount to be $1,485.947. Because it's dollars and cents, we want it to 2 decimal places. So the answer is $1,485.95. Now, I told you continuously should be a little bit bigger because it's compounded more often. So I'm going to do on this one, I'm going to do 0.08 times 5, get a number. Then I'm going to do e raised to that power. E raised to, I guess that's a 0.4 power. I take e to the 0.4 and then I multiply that by 1,000. That makes the amount to be $1,491.824. Now that does not round up, right? So the answer they're going to have is going to be $1,491.82. Okay, in the interest of time, I'm going to be going through these. So we want to evaluate these. So you could write it exponentially, do a fish hook. 3 to the y equals 243. 3 to the y equals 243 is probably a power of 3. It happens to be 3 to the 5th. The bases are equal, which means the exponents have to be equal. So this value is 5. Maybe you know that 7 to the 0 is 1. I don't know. You'd have to do 7 to some power equals 1. And the power would have to be 0. Anytime you see the log of a 1, it's going to be 0. Because what is anything to the 0 power? 1. On number 20, I'm going to do 125. This is the fish hook. Raised to the y equals what here? 1/5. 125 is 5 to the 3rd. 1/5 is 5 to the -1. When you have a power raised to a power, you multiply them. So now my bases are equal, my expressions are equal, so the exponents have to be equal. So what I'm going to write is 3y equals -1, and I'm going to divide it by 3. Okay, after 28, we want to expand. So the instructions here will be to expand. In other words, write with multiple logarithms. This one is going to be to condense. which is to write as a single logarithm. Just to remind everybody, I'm going to write the three properties here. Log of A times B equals log A plus log B. Log of A divided by B equals log A minus log B. And finally, if I have log of A to the B power, you can pull the exponent out front and call it B log A. So those are the properties I plan on using. I see a division here. So that means I can write it as a log of the top minus the log of the bottom, because the division turns it into the subtraction of two logs. Now, I also see a multiplication here. Hold on one second. Okay, I see a multiplication between the 3 and the y. That's like a log of A times B. So this could be the log of 3 plus the log of y. Because the multiplication becomes an addition of logs. There is only one step left, and that is to pull this exponent out front. So it would be minus 5 natural log of x. That would be my expansion. Again, log of the top minus log of the bottom, that's right here. Log of the top minus log of the bottom. Then because it's multiplied, you break it into the sum of two logs. And then if there's any exponents, like the 5, I pulled them out front. Now in condensed, we go the other direction. Now I want to take these numbers out front and put them up as exponents. So this would be ln of 3 to the second, or ln of 9, plus ln of 2 to the fifth, which is ln of 32, minus ln of 8. So all I've done is I put the exponents up and evaluated them. Now I see a plus between two logarithms. Do you see a plus between two logarithms here? So could I write it as the log of A times B? So what I'm going to do is I'm going to write it as the log of A times, let me make that purple, times B. So 9 times 32. 9 times 32 is 288. Now I see a subtraction between two logs. Do you see a subtraction between two logs down here in the properties? So that could be log of the first one over the second one, right? So this could be natural log of 288 over 8. Now that simplifies. Let's see what it simplifies. I believe that just becomes natural log of 36. Okay, I'm going to keep going. I think now we want to solve a couple, and I think that was just 3 more to solve. So 5 to the x equals 32. What do I know 5 to the 2 is? Is it bigger or smaller than 32? Smaller. 5 to the 3 is bigger. So I know my answer is going to be 2 point something before I even start. If it was a multiple choice, that could help you eliminate answers, right? Now, I'm trying to get the x by itself. Anytime the variable is in the exponent and you need to solve it, you have to use logarithms. Why? Because there's a property of logs that allows me to pull the exponent out front. So I get x ln 5 equals ln of 32. Now the opposite of multiplying by ln of 5 would be to divide by ln of 5. So your answer is going to be x equals ln of 32 divided by ln of 5. as a approximation, you might call it ln of 32 divided by ln of 5. As a decimal approximation, it is about 2.1533. Again, the top one's an exact answer, the bottom one's a decimal approximation. I like both. Number 33, can I do the fish hook? 3 to the 2 equals this. So that's what I'm going to write. 3 to the 2 equals 2x minus 5. What is 3 to the 2? Well, it's 9. If I add 5, that makes it into 14. If I divide by 2, that makes this thing equal 7. Now just check. On logs, you got to check. You can't take logs of zeros or negatives. If I put in a 7, that's 14 minus 5. That's not the log of a negative, is it? So I know this one works. Okay, the final one, again, we have 2 logs added. So that becomes the log of the product. So it's x times x plus 2. The base of a natural log is e. So you could do the fish hook. E to the 3 equals this argument. E to the 3 equals x times x plus 2. That means x squared plus 2x minus e cubed equals 0. To solve it, it's obviously not going to factor. You need the quadratic formula, which I'll write out again. It's from Algebra 1, 4ac all over 2a. Negative b would be negative 2. The square root with b squared would be 4. 4a, which is 1, c, which is negative e cubed, all over 2a, which is 1. So negative 2 plus or minus, this becomes 4 plus 4e cubed, all over 2. I hope you've done enough to know that you need the bigger one. The bigger one is the one that says plus, not the one that says minus. The reason you want the bigger one is the smaller one probably is going to be negative. So let's compute these values. I have negative 2 plus the square root of 4 plus 4e raised to the third. So I want that number divided by 2. And I get 3.591. What if I had negative 2 minus the square root of 4 plus 4e raised to the third? Take that number divided by 2. And this is negative 5.918. If I put that in, that would create the log of a negative, which I can't use. So there's really only one solution. There it is in precise form and as a decimal. I hope these help. Good luck. We're going to be testing Chapter 4 next time I see you.